So my name is Gary Allenby. I'm the Chief Scientific Officer of Aurelia Bioscience Limited. Aurelia Bioscience Limited are a contract research organisation that delivers to our clients preclinical contract research. We use reagents supplied to us by commercial suppliers, and we build assays using those reagents, or we identify reagents that we require in order to obtain from other sources, and then we screen compounds and biologics in well plates. We're really interested in the NanoBreath-T project, particularly from the point of view of kinases. We have a technology ourselves, which is an electrospun fiber that we utilize in well plates for screening purposes. What happens with the electrospun fiber is that the cells stick to and adhere to these electrospun scaffolds, these small sponges that we have in solution. So what we did was we transfected into those cells the target engagement reagents for different kinases. And then we looked to see, by using the different traces that are available, whether we could compete the traces off the kinases with different compounds, and look to see whether the assay format worked for us by moving the scaffolds from well to well. We decided to go with the NanoBreath-T technology because we looked at it in comparison with the other technologies that were available. In terms of the biochemical assays, really we feel like we want to do more physiological assays, and taking the kinase out of a cell and having it in a solution was not as physiological as it could be in its native environment within a cell. Hence the reason why we thought it would be most appropriate to use the Promega technology in order to have the receptor in a native environment within a cell at physiological ATP and also a physiological pH. We investigated different ways in order to read the breath signal, and we looked at a number of different reader plate technologies, and those included Envision from PerkinElmer. However, we were more than happy with the reader that we obtained from the GlowMax instrument from Promega. So we went ahead and utilized that one for our studies. But really, we feel that the future lies in more physiological well-based assays. We're always looking for interesting and new ways and new technologies to be able to prosecute those. And we're combining at the moment the scaffold technology that I've mentioned with many of the other reagents that are available, most interestingly the ones from Promega, in terms of looking at kinases, GPCRs, in order to try and get a more physiological way of testing the activity of the compounds in the well plate assays.